Namaste to all. Today we are going to know about our dialyzer in hemodialysis. So today we are using a F6 dialyzer as an example for our class. So if we thought that this is a F6 dialyzer, so there are two side coupling zone from where dialysate in and another one is used for the outlet for dialysate. So in dialyzer there are membranes, lakhs of membranes. Those membranes are mainly synthetic membrane. Okay, so previously we use cellulose membrane, semi-synthetic membrane, but in new generation we use synthetic membrane because it is more biocompatible. Okay, those are not as biocompatible as synthetic membrane, and different company are named different membrane, like Fresenius name is polysulfone and Helixon membrane. Nephro have some another name, Gambro have some another name. From one side dialysate, get into the dialyzer, and the another side, from another side dialyzer get out. Dialysate inside, dialysate outside. From one side blood came into dialyzer, blood inside and blood outside. So if we think that the flow of dialysate and blood in the dialyzer, those are always in opposite direction. This is called counter current mechanism. Okay, if those flow are in the same direction, then it is called co-current, and that is called counter current. Counter means opposite, current means in Bengali we call it স্রোত, নদীর যে স্রোত সেই স্রোত. Okay, so opposite directions current called counter current mechanism, and if it is same direction then it is called co-current mechanism. So in our main topic about dialyzer, there are membranes, millions of membranes. So if we zoomed a membrane, it is looked like a hollow tube with various type of pore in it. So blood come from this way and passes through membrane and goes to patient. Okay, blood, and we know that dialysate are in the outer part of our membrane. Dialysate. So when blood passes through this membrane, due to oncotic pressure and hydrostatic pressure, and with the three main principle. What is the principle in hemodialysis? HD principle are first one diffusion, second one convection, third one ultrafiltration. So in the process ultrafiltration, fluid from this blood comes out. Okay, and with fluid some molecules are comes out which size less than pore size, because if fluid comes to that pore, then the molecule will be removed from that pore. Generally it will be smaller than that pore size, like this. Okay, so those are smaller molecules which comes out with the fluid. That process is called convection, and removal of the fluid is called ultrafiltration. And there are some molecules also in dialysate which passes through these pores and mixed with blood and passes through with blood. Those mechanism is done by diffusion. So there are three mechanism. Now we can understand those mechanism, that diffusion, convection and ultrafiltration. Now we can understand the three principles of hemodialysis. Okay, if molecules are much bigger than that pore size, if we thought a molecule is size like this and the pore size is like this, then it generally can't pass that pore, so it passes through the membrane and goes to the patient, goes to that patient. Those are mainly proteins which are generally in big size. So we have to know the pore size of every dialyzer to determine that is a high flux dialyzer or low flux dialyzer. So if we thought it is a membrane, then if a pore size is smaller, then it will be low flux dialyzer, and if a pore size is bigger, then it will be a high flux dialyzer. In some new membrane, there are much bigger pore, which is called super high flux or protein leakage dialyzer. Understand? So in case of pore size, we classify dialyzer in three parts: low flux, high flux, super high flux. And in UF, fluid removal rate, generally fluid removal depends on the how much membrane are there. So if there have a two membrane and in a dialyzer, for an example, and if a dialyzer have 5 membrane, then the number of pore is much higher in that 5 membrane dialyzer than 2 membrane dialyzer. So fluid generally will remove much easier in 5 membrane dialyzer. So it is called surface area. So if a dialyzer has more surface area, then the UF removal is much easier. That is called ultrafiltration coefficient, KUF. So surface area high is high. If surface area is high, then the KUF will be high. If low surface area dialyzer, in low surface area dialyzer, KUF is generally going to be low. And the third part in our topic is KOA. This is called urea clearance. Generally, urea is distributed in the whole body of a patient. So we used urea as a clearance mechanism. If we think that there are much more pore, then fluid will remove much more. Generally in high efficiency dialyzer means large surface area dialyzer, but if there is much more membrane with bigger pore size, then it will be a very effective in clearing the molecules, because large number of membranes are also help, and large pore size also help to remove the molecules from the blood. So if a dialyzer have larger pore size and surface area also large, then the KOA means clearance of urea and other electrolytes also will be higher. In this part we make a chart of KOA means urea clearance, KOA means ultrafiltration clearance, means how much water is going to remove. Beta 2 microglobulin is a larger size molecule and pore size of a dialyzer, and molecular cutoff means how much size of a molecule is going to pass through that dialyzer. So in low flux dialyzer like F6, the clearance of urea is 500 ml per minute less than. KUF will be 10 ml per hour per mmHg. Beta 2 microglobulin rate will be less than 10 or nothing. Pore size will be 1.8 to 2 nm, and molecular cutoff will be 100 to 5000 Dalton. Then high flux dialyzer, then high efficiency dialyzer means F8 or F10. It is urea clearance 600 to 700, KUF 10 to 12. Beta 2 microglobulin rate is similar to low flux, it's less than 10 or 0, and pore size will be 1.8 to 2, because those are same dialyzer but the membrane number is higher in high efficiency dialyzer. So UF means fluid will remove easily more than low flux dialyzer. Only KUF will be higher. Understand? And molecular cutoff is also like the same. Low flux dialyzer is 1K to 5K, means 1000 to 500, 5000. High flux dialyzer, here high flux means pore size will be more than low flux or high efficiency dialyzer. So the KOA will be increased from 600 to 800. KUF also will be increased 15 to 20. Beta 2 microglobulin rate will be removed 20 to 50 ml per minute. Pore size 3.2 to 6.6, and molecular cutoff means 15,000 to 25,000 Dalton size molecule will be removed. Super high flux, in that 45 to 60K Dalton will be removed, just less than a albumin size. Albumin size is 66.5K Dalton. So albumin is like this, and molecules are going to pass like this. Example. And here the urea clearance 800 to 1000, and beta 2 microglobulin it is very important 50 to 80. So this is a basic information about our dialyzer. Thank you.